Hello dear students, in this video I am going to explain the phase of a wave, and then I compare with the progressive wave and the stationary wave, and I found the phase difference. Okay, let me define the phase of a wave. Phase is actually the angle that describes the position and direction of motion of any particle. So for example, if this is our wave and we can compare this wave motion with the simple harmonic motion or with the circular motion, because we know that the wave motion is just like a circular motions, okay, because it follows the same rules, same angles, okay. So for example, if the wave is at this beginning point, at the starting point, so at this point so that the phase is 0 degree, then as long as this particles goes up, so mean at this position at the 90 degree, so this particle on the circle moves upward, so that the phase is 90 degree or pi over 2 radian, 90 or pi over 2. So similarly, when this particle goes downward at this point, that is 180 or pi radian, 180 degree or pi radian, so this particle on the wave also goes 180 degree or pi radian. Similarly, for the next movement of the particle, so the wave, the point is that the angle is phase is 270 degree or 3 pi by 2 in radian. So this point is at 3 pi by 2 or 270 degree. And last one is the 360 degree, or you can see that here we have the C60 is same as the 0 degree or 360 or the 2 pi. So the angle in radian is 2 pi radian. Okay, these points are the wave. This when we start the wave, here the point is 0 degree, or 0 radian, then 90 degree or pi over 2, 180 degree or pi radian, 270 degree or 3 pi over 2 radian, or and then for the complete wave, for the complete T, we have 360 or 2 pi radian. Okay, so this is a wave. These all angles are actually the phase. These shows the position of particles, and they also shows the direction of motion in which the particle is moving. Okay, now we move forward and we discuss the phase difference. What is mean by phase difference between different points? So the phase difference is actually, you know that the different particles are moving different ways. So phase difference is the difference in phase. You can compare with the different points. For example, we can analyze different points. So I made A, B, C, D, E, F, G. So I made different points. So some points are have the same point, same direction. Okay, some points have the same direction. So it means if A point is moving upward, so this H point is also moving upward. So you can see that the phase of A is 0 degree and H is also at the 0 or 360 degree. So A and H are in phase. So in phase points are A and H are in phase. Similarly, we compare with the B and I. B is exactly at the same position as the I is. B also has the same displacement as the I is. So we have B and I is also the in phase. So C and J, C point and J point is also in phase. C and J are in phase. You can say that why A and H are in phase. You can see that A is at 0, H is also at the 0 degree. So 0, both are at 0, mean both are at the 0, so they are in phase. So you can compare if this B point and I point, it's, for example, it is, if it is at the 45 degree, so this I will be also at the same position 45 degree. So the B and I also has the same phase. C and J, C is at the 90 degree, J is also at the 90 degree. 90 degree or pi over 2 or pi over 2, and this J point is also at the 90 degree or pi over 2. So they are also at the same phase. So similarly, we can compare different points. Okay, so if we compare G and L, G and L also in the phase, same phase, are in the phase, in phase. They have the same phase, mean they have the same phase, they have the same angle. Now, which points are the out of phase? The points that are out of phase are, for example, you can compare either points, just like C and G are out of phase, C and G are out of phase, C and G are out of phase. Okay, now why they are out of phase? You can see that a C is at the angle the C makes is 90 degree and G makes is 270 degree or 3 pi by 2. So they are separated by what is the phase difference between C and G? So you can compare the 270 minus 90. So that the 270 minus 90, that phase difference is 180 degree. 270 minus 90 degree. So the phase difference is 180. So they are anti-phase or 180 out of phase. Similarly, you can also compare any 2 points. For example, if we compare with the C and J, they are also in phase. For example, if we compare C and K, for example, C and K, let me check. C is at 90 degree, K is at the, you can see that the second wave start from here 0 degree, 90 degree, 180 degree. K is at 180 degree. So C is at the 90 degree, K is at the 180 degree. C is at the 90 degree and K is at the 180 degree. So the phase difference is clearly 90 degree. So that the phase difference is 90 out of phase. These 2 points are 90 out of phase. So just you can check all the points, the angle, and then find the difference between the 2 points. Okay. So this is the progressive wave. So what about the stationary wave? So stationary waves is something different, because in this stationary wave, the particles are moving up and down. There are some points in which the particles at the rest, just like nodes. At the nodes, the particles have no displacement, has zero displacement. But at the antinode, at the highest point, the particle is moving at the antinode. These particles, all other particles are moving up and down. So because you can see that red color is actually the particle. These all particles, when they are upward, so their motion is downward. So when they upward, they moves down, then they go up, then they move down, and then they go up. Okay. So we can find the phase relationship, phase difference between any 2 particles. Okay. So simple formula is, we have 2 equations, 2 formulas. For example, one is if particles are separated by even number of nodes. If any two particles are separated by even number of nodes between them, then their phase will be 0. They have no phase difference. The particles are in phase. For example, if we compare with the A and all other particles from this point from between these 2 nodes, because these all particles have the 0 node difference, because they are on the same node. For example, if 2 particles on the same node, so they have these all particles have same direction. You can see that all particles are moving downward. So when they are moving, all the particles are moving downward, so it means they are in phase. They have 0 phase difference. Similarly, you can also compare with the other particles. These particles here, you can see that these particles also moving downward, because this wave is going downward and this wave is going upward. This wave is going downward, this wave is going upward, this wave is going downward. Okay, so one portion, half wave is going downward, one wave is portion is going upward. So you can compare these two. They both have the same direction, so they are in phase. So when you compare with this node, difference of node, for example, this point, for example, I say that this is for example, I can compare, for example, this is A point and this is B point. So when we compare A and B, so in between we have 2 nodes, 2 nodes. So difference of 2 nodes mean the even number of nodes. Even number mean 0, 2, 4, 6. If we have a difference of 0, 2, 4, 6 nodes, then the waves is in phase. The points are in phase. So A or B are in phase because they have 1, 2. The difference is 2 nodes. The difference between these 2 is 2 nodes. So they are in phase. Similarly, for the points that are in the 6 node, for example, 6, this point is C, for example. All the points in this point C have the same phase as A and B. All the particles in same phase. Similarly, we can compare with the 8th one. So this because we know that 1, 2, 3, 4. So that the odd number, even number of nodes. Their difference is even 4 nodes. Difference between This particle A and C are actually the even number of nodes, so we have also in phase. These particles are all in phase. Okay. Now what about when if the particles are separated by odd number of nodes? Odd number mean 1, 1, 3, 5, 7, 9. This is a general rule that you can apply. 1, 3, 7, 5, 9. Okay. For example, if we compare it with the A with the this D particle, so when we compare with the A and D particle, so we have the one node difference of one node, mean the odd number of nodes. So in other words, because this particle is going downward and this particle is going upward, so they are anti-phase. They have the 180 out of phase. They have the 180. A and D are 180 out of phase, because they have the one nodal difference of one node between these A and B. Similarly, you can compare A with the third nodes, for example, 1, 2, 3, three nodes, and then this point. For example, there is another point E. So A and E also has they are anti-phase, 180 out of phase. Similarly, E, and then we can take F. This point is also F. For example, this F is at the difference of 1, 2, 3, 4, 5 node. The internodal distance is 5. So the A and F are also 180 out of phase. So general rule is, if the particle is separated by odd number of nodes, then phase difference is again 180 degree. So either in stationary wave the particles are in phase, zero phase difference. Even if they are in the same line of between two nodes, or either they are separated by even number of nodes, 0, 2, 4, 6, so on. And if the particle separated by odd number nodes, must mean 1, 3, 5, 7, 9. So they are 180 out of phase. Okay, thank you.